Hello, everybody, and welcome to today's webinar. We're back after a short break, and this time we will look at cloud security strategies. The idea of the session came about as the cloud is becoming incredibly popular among companies around the world, and so that makes the conversation around cloud security essentially unavoidable. Today we'll look at the core of cloud security, so the shared responsibility model, and how, with that in mind, we can make sure that our sensitive assets in the cloud, be it customer data, product data, patient data, how this information is protected. My name is Eve Reitza, and I'm a technical consultant at Protegrity. And as usual, I'm joined by Simon Brender, our General Manager for Asia Pacific. Again, we have muted all the lines, so in case you have any questions, email us directly or put these questions in the chat box, so we will get back to you. This is what we've prepared in the agenda today. It looks pretty compact, but be certain that we've packed a lot of stuff in these 4 points. We'll start by looking at the cloud, why is it the new technological default, how that came about, and what sort of challenges this brings for the companies. Then I'll introduce data-centric security model for the cloud specifically. And then we'll move on to the main focus of today's session. So various architectures and examples on securing software as a service, platform as a service, and infrastructure as a service. And then finally, I will talk about Protegrity in the cloud, different system configuration options, as well as multi-cloud environments. Yeah, cloud technology is becoming the new default option. This is what we've learned from a couple reports that came out last year and this year. For example, what IDG Communications report surveyed is that apparently 9 out of 10 companies have already moved some of their applications or computing infrastructure to the cloud or plan to do so in the next 12 months. And that's an amazing number, because it also says that we're past the hype, that cloud is actually the reality. Another thing that they've reported I found pretty interesting is they've created this average IT environment today, something that perhaps doesn't exist but tells you a lot about how IT environments look like today. So this average theoretical environment would have, and this is all based on real survey data, right? So this theoretical environment would have about 50% of all the information will be still based on premise. However, as you see, software as a service is definitely leading the cloud adoption, with companies having about 1/4 of all their assets in SaaS, followed by platform as a service and infrastructure as a service. And what I found particularly interesting about this metric is that IDG predicts, based on their responses, that the non-cloud part is going to shrink to only 30% in the next 18 months. So the rate of acceleration is absolutely staggering. However, of course, the fact that the cloud adoption is growing, it doesn't mean it comes without any sort of challenges. And that's another thing that has been surveyed. What sort of challenges the companies see in implementing cloud? And number one challenge is apparently vendor lock-in. Another bit is around security, so that's one of the top challenges as well. And there's also a lot of concerns around where the data is stored, about the lack of skills to manage the cloud and get the best out of it, and also around integration. Our focus as a security company is, of course, the security concerns, and this is what we will help you with. However, I think you will see it throughout this presentation that the right security helps and eases a lot of these other concerns as well. Talking about security, one of the things we need to discuss when it comes to cloud security is the security responsibility model. And it's something that I think perhaps not everybody realizes when they move to the cloud or when they consider the cloud. There's essentially 2 parts to that responsibility model. The cloud provider is responsible for securing the cloud infrastructure, whereas we are responsible for securing your data. And this is essentially the core of cloud security. If you think about data breaches that happen in the cloud, this is very rarely due to the actual cloud provider. These sort of systems are essentially very secure and very well configured themselves. It's mostly us who underestimate some of the security measures that we should be taking, like the right network security, making sure that the data that we put in the cloud is already secure. So all these sort of things are essentially the base of data breaches. This is what Amazon puts on their website, just to give you some more food for thought. They clearly state that their responsibility is security of the cloud, so all sorts of things, hardware and software on the database and compute and storage level. However, everything in the cloud, and that means the applications, the network and firewall configuration, and most importantly, the data, this is all the customer's responsibility. And data-centric security can help address these challenges, and this can help ease the transition to the cloud. What's data-centric security? I think the easiest way to explain it is to take a step back and see how security works normally. What all the customers have in common is that they have some sort of data assets they most likely would like to protect. And the traditional way of dealing with this problem is to build walls around these data assets. And that we normally things like network security, perimeter security, firewalls, all this sort of stuff, right? However, as soon as somebody from the outside, or an insider actually, manages to go through these walls, there's nothing stopping them to get to the core of the data, because all this information is normally stored in the clear. That means all of our social security numbers, all of the product commercial information is out there in the database or in files stored in the clear. So data-centric security says that really the only way to protect the data is to protect the data itself. Because if that sort of situation happens and a person manages to go through all of our security walls, we still make sure that what they see is absolutely meaningless, because we've substituted our data with tokens, with encrypted values, what have you. So how does it work in practice? To me, there's essentially three main points in applying data security policy. And of course, if you're interested in more detail around it, take a look at our first session, Introduction to Protegrity, where we explain these different settings in depth. But essentially, there are three main parts to applying data-centric security. You define a data security policy, so what you want to protect. You implement our software, and then you deploy this policy. You send it to the agents monitoring the data store, and you make sure that you keep an audit of everything that is happening. So starting with defining data security policy. A data security policy consists of, I would say, four main things. However, there's a lot of other stuff you can configure and you can think about. First being the data. So this is the moment where you have to think what data should be secured in your company. For example, are we securing all the names of our customers, all the social security numbers, all the telephone numbers? Are we secure? What sort of data are we securing in terms of the product, in terms of financial data? And this sort of thing is done, has to be done by a team, by the subject matter experts as well, in order to create a very good data security policy. Then you can also you also have to know where this data lives, and for that you can use different tools. You can use Protegrity tools as well, that with machine learning help you find where these data live across your whole environment. Then once you decided that, you need to think about what sort of protection techniques you want to use on that data. Do you want to use tokenization? Do you want to use encryption, masking, etc.? So, for example, do you want to, in terms of encryption, this is essentially replacing original data with a ciphertext by using a mathematical algorithm. So there is a mathematical relationship between the output and the original text. Then you can use tokenization. I think it's a less popular option. However, it's just as secure as encryption. And tokenization essentially replaces the original value of a token with a representative token. And it keeps the original data format, keeps the original data length if you want to. So it's actually a pretty good option if you want to, that really speeds up or eases out the problem of integration. And then, of course, masking is essentially replacing these values at the presentation layer with a mask. So you decide that. You also decide who should have authorization to data and to what extent. So perhaps most of your organization shouldn't have the access to the data in the clear because they don't need this information to perform their everyday job function, right? You can also define in the policy to what extent. So you can say that a certain person can, for example, see only 3 last digits of a credit card number, but nothing else. So all these different configurations are available. And you can also, of course, integrate it with an LDAP system. And then finally, you decide what you should be monitoring. So is it all the protection operations? Is it all the unprotected attempts? Is it all the successful ones as well as the unsuccessful ones? So do we want to see if people keep accessing a certain element a lot of times and they fail, or they're successful, and that's also something interesting. Then after we decide that, we have to install Protegrity software, and Protegrity has a lot of options in terms of our technologies. So on one hand, we have various native protectors, and that's specifically true for big data, for databases, for mainframe. We have also some gateway technologies and Java protectors and C protectors to integrate with your whole environment. And we'll be looking at this in much wider extent later on in this session. And once this is installed, what essentially happens is our main component, Enterprise Security Administrator, where you define the data security policy, sends this information to all these endpoints. And this is where the security policy is applied. And every time a protection and unprotection happens, this happens on all these different stores or through the gateways. And then all these endpoints send logs back to ESA so we can monitor them. And that's in a nutshell. If you're interested in any of these topics in a larger extent, so for example, how to create this policy, watch our first session, Introduction to Protegrity. If you're interested in what constitutes sensitive data, for example, we've talked a lot about it in analytical environment session, as well as data monetization. Now, with all these sort of things in place, what you can achieve is, first of all, you make sure that your data addressed in the cloud, and as it goes to it and it's read from the cloud, is secure. So you fulfill this main point in data security. You make sure that if a data breach happens, the data that the potential outside actors get is absolutely meaningless to them. Another big benefit of the solution is that there's one solution for many technologies. Once you define your data security, your data security policy, this is the same for the software as a service, platform as a service, and infrastructure as a service, which means that you have define the same policy for your Teradata on Amazon, for your Oracle on Oracle Cloud, for your applications as well. And there's no all this key management going around the system because we centralize it in one component. There's also no conflicting solutions or solutions of different level of security. It really makes the implementation and integration very easy. Then finally, we also help with preventing vendor lock-in when you think of that, because if you say decide to put your data up in the cloud and you protect it with Protegrity, you can just as easily remove it from that cloud and move it to another cloud if you want to. And there's no need to unprotect this data and then protect it again. No, you just move these tokens or ciphertext freely across your environment. And so with these characteristics, one thing you'll see is that adoption of the cloud is way easier, because right at the beginning, we make sure that the data is protected. So all these sort of misconfigurations I've been talking about, or the lack of knowledge, is actually not that much of a problem, because you're breach proof if you make sure that your data is protected at rest. We also make sure that you're compliant with the new regulations. And also it adds this another layer of protection against, for example, other governments that sometimes have legal rights to access the data that lives outside their country boundaries, like it is the case with the US Cloud Act. So a lot of benefits if you apply data-centric security. Now let's take a look at different architectural options for data protection in the cloud, starting with software as a service. So one of the mostly adopted cloud options. For SaaS, Protegrity follows one classic architecture. So let's say we have a client and we have a cloud application. And what happens as soon as this client sends a post request? So let's say they want to create some sort of a web form. We intercept this information with our cloud gateway, which acts essentially as a reverse proxy. So cloud gateway cloud gateway intercepts the post request. It scans the payload for sensitive data as we defined it. If it finds it, if there's some customer data, if there's anything that we think is sensitive that we have defined in the data security policy, it protects it, and this is how the data is written to the cloud application. And then at the point where, and this is how the data also lives. So if you, for example, decided to bypass cloud gateway when reading this information, the only thing you're going to get is tokens or ciphertext. And at the moment of reading the data, what happens is the data again flows through the gateway. The gateway decides if the person has the right authorization to see this data in the clear or not, and then it returns the data. So it could be that if a person doesn't have authorization, the only thing they're going to see is, again, protected values. It could be that they have authorization to some of the data, to some they don't, so they have a mix. And then finally, there will always be users that have access to the data in the clear, and this is what they'll be returned. And this is essentially how we apply a protection to SaaS applications. Normally, we use Cloud Security Gateway or Data Security Gateway. This is essentially the difference is where you put it. So you can have Cloud Gateway in the cloud, you can have it on-prem, and this is how it works. It intercepts TCP/IP application layer protocols like HTTP, SMTP, SFTP, SSH, and it looks for any sort of sensitive data in them. And as we decided to configure that in the policy. And the good thing about this architecture is that it can be applied to many SaaS technologies. So whatever you have, could be even actually in the last couple of weeks or months, I've seen myself and my colleagues working with Salesforce, with ServiceNow, with Workday, with Box, with Okta. So these things are very, very common and very often protected with Protegrity. As an example, I wanted to show you one of my latest projects, protecting ServiceNow. This is the situation we had. This is the use case we had. So I have to admit, I don't know the full capability of ServiceNow. It's not in my region of expertise. However, what we were looking at is the incident part of ServiceNow. So the idea was that somebody would create an incident, And as soon as this information was sent to ServiceNow, we would protect it. So the data was stored, protected, at rest. And then if a person was authorized to see this information, so for example, they were assigned to that particular ticket, they'll be able to see the data in the clear. If they didn't, if the ticket wasn't assigned to them, they would only see essentially masked data. And there were also like a couple of different variations of this use case. So we added also regionality to this. So accessing ServiceNow from a country that wasn't authorized to access it would also show you, for example, mass data, even though you were the ticket owner. So all these sort of cases. This was the design, very simplistic in a way. As I was saying before, Cloud Gateway was, as in our standard architecture, Cloud Gateway would capture all the requests, would scan it for sensitive data, and will save it in ServiceNow protected, and then it will, on the request to read the data, it would always see whether the user is authorized to see the data in the clear. The policy came from Enterprise Security Administrator, and this is also where we would send our logs on who accessed the data. And in the scenario, just so you get a better idea how it worked in practice, you would have, say, a site surveyor that created an incident, and that information would be written to ServiceNow. So again, in our case, that was Data Security Gateway that would intercept that post request, scan it for sensitive data, and return it to ServiceNow. And this is how the data would live there, essentially protected. So we've protected the description of an incident. And as you see, every incident is assigned to an owner, and this is another key in this design. So this part talks about how different users access this data. I will have 3 users. I'll have an admin user, a technical user A, and just a random user that's also part of our company. So as soon as there's a read request, again, this data goes through the gateway. And for example, in the case of an admin, what we decided is to show all the information to clear, because perhaps this person has to reassign the incidents, what have you, and they need to see what incidents are happening. Technical users only ever have access to incidents assigned to them. So as you see, my technical user A can only see in the clear the short description of an incident that they have to work on. However, they can't see incidents that are assigned to other users. And then finally, another user would just simply see everything protected because they're not authorized to see this data in the clear. Another sort of example is Box. It's different to applications such as Salesforce, such as ServiceNow, because this is a file share software as a service. So in the Box design pattern, this is what would happen. So Box would have some sort of information. It could be CSVs, PowerPoints, Excel, documents, various stuff. And again, we'll put Cloud Security Gateway in between the Box environment and the clients. And Box Security Gateway would intercept files sent and downloaded from Box. So in practice, imagine we have a technical user and that person sends a file to Box, say it's a CSV file. Data, the gateway scans it for sensitive content. So for example, maybe it has some financial data in it. It takes this data out and protects it. So it's written in tokens, let's say. And this person, if they want to read it, they can see the data in the clear. That's not a problem. Gateway authorizes them to do so. For other users, such as for business analysts, we can define that this person would only see the data partially protected. So imagine we've protected 2 columns in Excel. We said, protect the names and protect the financial information. Perhaps we want to show the numbers in the clear to the business analyst, but we want to keep information about the customers or the products protected. And then finally, we have another user. If that person decides to download data from Box, they will only see it protected. And this is the same for also to files. Of course, some can be protected in a more fine grain than others. Like imagine video files, right? But to some, we can apply really fine grained security like CSVs or even documents and PowerPoints. Now a couple of examples of protecting platform as a service. An example that very often comes up is big data in AWS and Google Cloud. And I'm happy to say that we have a dedicated big data protectors for AWS and Google Cloud computing engines, which is on one hand the Dataproc in Google, and on the other Elastic MapReduce. So what it means is that, what a native means is that you, as soon as you want to spin up that cluster, you add our Protegrity native protectors, and this is installed on every single node of a cluster. And another thing is that if you're using automated scaling, the protectors are replicated to the new nodes automatically. So it's a pretty sleek system. You don't have to do much manual work. And the big data protectors also work because, of course, big data is a big term, but we have big data protectors that would integrate with MapReduce, with Spark, so two major computing paradigms. We also have options for Hive, for HBase, for Pig, Impala. So a lot of different configurations you might want to use. Another typical PaaS solution that we come across is Google BigQuery. And I want to talk about some configuration options in terms of protecting this platform as a service solution. So one hand, what you can do is, and I would like to bring your attention to the right-hand side of the diagram, so where the BigQuery actually is. So here what we recommend, if you want to use BigQuery in the cloud, is that the data is stored, protected. It's BigQuery works on that protected data, and only at the level where you want to return this data to the user, this is the moment where the data is unprotected. And this goes past our DSG or Cloud Security Gateway. Another pattern that we've been recommending is sort of reversing the order, so that we allow BigQuery to work on the data in the clear, because we put the DSG. It should actually say CSG because it's a Cloud Security Gateway. We put it before BigQuery, so that BigQuery works on unprotected data, and this is what it returns. And of course, this sort of architecture can be applied to other sort of services. Now let's move on to infrastructure as a service. There's a variety of IaaS-supported use cases. But I think the first thing that I think is important, and this is one of our flagship use cases and recommendations, is that what we always say is that it's better, if you can, better to protect the data before landing, because that means you're eliminating any sort of moment where the data is stored in the cloud storage in the clear. You make sure that the data is written already protected. And then if you wanted to unprotect this data and show it to the end users, you can, for example, use, you can embed our Protegrity functions in your application. So that will be possible with, for example, our Java application protector. You have some sort of software and you embed these sort of functions, and then the data is unprotected at the end stream. Two other patterns to protect data stored in cloud storage is also using our data security gateway as a REST API. And DSG can be on the cloud or on-prem. And what you would do is, and this is an example where you don't have the luxury to protect the data before landing. So you have some data on the cloud storage, and what you can do, you can call our REST API, protect this data, and write this data back protected. That's another pattern that is possible to do. And then finally, there's also something we call a pull mechanism, and this is available for AWS S3 buckets or for NFS systems. And in this scenario, we use data or cloud security gateway to monitor the storage. And as soon as the cloud security gateway finds new files, it will take these files, scan them for sensitive content, and write back protected. So again, a very interesting option. When it comes to, for example, Google Cloud Protection, another topic that comes up very often, or rather, this is actually the same sort of idea, right? So you still want to make sure that your data is protected before it lands on the cloud storage. And then as soon as you want to unprotect it, what you could do is the same sort of scenario we talked about before. So you could embed our protection engine in your application, in your software, right before this data is returned to the end user. In this case, it will be, for example, the Java protector. Another possibility is to use DSG. So after the software layer, you can, and before the data is returned to the client, you can have DSG intercept or Cloud Security Gateway intercepting that transfer, scan it for sensitive values, and then unprotect or keep protected depending on the user authorization. So these sort of things we recommend for Google Cloud Platform. Then another important topic, and this is something I sort of skipped on Platform as a Service, but you will see that this is essentially connected, that we have a very wide coverage of different technologies. We have native protectors for all these sort of systems. And for us, in the end, it doesn't really matter where they live. It could be any sort of cloud system. It could be on-prem. It could be their own proprietary cloud. So as in the case of Oracle, right? What we will do is we install dedicated protectors on every node of the supported systems, and that the protection operations are. This helps and protectors essentially use the computing power of the underlying systems. So if these are 6 node, if this is a 6-node cluster, this is the protection speed is also accelerated, right? And of course, as a side note, now I have to add that protection is essentially adding very little overhead that we estimate. And so as I was saying, if you have, for example, your Ali Cloud or your AWS and you're running Teradata there, this is where you would install the Teradata protectors on every single node of that cluster. If you have an Oracle Cloud and you want to protect your Oracle database, again, for us, it doesn't matter where this is running. We'll still be able to install our protectors. How does it work in the case of how does it work in the case of our native protectors? This is one of the scenarios. Imagine you have a data scientist and they want to run some sort of a query, like select name and date of birth from the customers. And we also have at the bottom of the screen, we also have some sort of a storage mechanism. It could be a database, it could be Hadoop, and this is where the data lives at rest. It's protected. As soon as this person sends a query, our policy enforcement agent will kick in, and it will check whether this person has the authority to access the protected data. If they do, then the data is sent in the clear, and the logs are sent back to ESA. In the case of an unauthorized user, it's very similar process. They will send the request. The agent will start. They will check whether the requester has the authority to access the protected data. If they see that they do not, they send the data just as it lives in the database, and the information is sent back to EASE. Again, this sort of architecture is available for both platform as a service and for various software solutions on infrastructure as a service. And then finally, let's talk about Protegrity itself. What sort of things in the Protegrity stack are available in the cloud? So on one hand, we have native protectors and we have Java protectors, and these sort of things are, it's just software, so you can put it anywhere you have. But we have also two components that can potentially be put in the cloud. And this is Enterprise Security Administrator. This is our self-contained key management system. This is where you define your data security policy. This is where you define your user roles and do all the monitoring. And this can be deployed in the cloud or on-premise, as you prefer. We now support AWS and also Google Cloud. It's the same for our cloud security gateway. So our gateway that intercepts all sort of traffic, you can put it on-premise if you want, but you can also put it in either of these cloud solutions. And then another thing we've tested recently is that for extra security, if you want to, you can integrate with external cloud HSMs. Protegrity includes its own stealth HSM in Enterprise Security Administrator, but if you need a higher level, you can also use a cloud HSM. And finally, a very interesting topic, and I think a summary of today's session, multi-cloud deployments, different system configuration options. It can happen that parts of your system live on-prem, parts of it live, perhaps you have some SaaS solutions, perhaps you have some data in Amazon and some in Google Cloud. So of course, since we've been talking a lot about how this is just one solution for all these different technologies, this is also available across different cloud vendors. So imagine this scenario. I have, on one hand, Google Dataproc on Google Cloud Platform. I have an Exadata in Oracle Cloud. I have a Teradata in Amazon. I have a Kafka cluster in Alibaba Cloud. And I have a couple of SaaS solutions all over the place. So what I can do is I can have one central data policy for all these different solutions. I can also put my Enterprise Security Administrator and Cloud Gateway in the cloud, either on Amazon or Google Cloud. And so if I wanted to protect and unprotect this data for the SaaS, it's as we discussed, you would use it with our Cloud Gateway. You would intercept the traffic to and from these SaaS solutions. And for all these others, we have a whole variety of options. For Google Dataproc, you would use our Big Data Protector. For Exadata, you would use our Oracle Database Protector. For Teradata, a Teradata Database Protector. For Kafka, a Java protector would be good. You can integrate it within Kafka, within one of the interceptors before this data moves to the topic. So all these different possibilities, and of course this diagram doesn't explore all the options, but as you see, Protegrity is not bounded by any sort of underlying cloud vendor. You can freely move these different, if you decide to move from one vendor to another, this is not a problem. You can also combine this data in your applications, in your BI, in your reports. If you decide to run a uniform report on Teradata and Exadata, you can do it because referential integrity is maintained. And that means that if on one hand side we store our clickstream data, on the other we store our customer data, it's very easy to, there's no extra processing in merging this data for reporting. So that's making it all way easier to integrate. As I was saying before, I know our main focus is data security, but it also influences other things such as integration, such as making the adoption of the cloud smoother, or making sure that you actually don't care where the data is stored because the data is always protected. We've covered a lot of things today. We talked about the cloud, we talked about the trends, where it's going, and how companies are adopting cloud on a massive scale. Then I introduced data-centric security for the cloud and how this works in practice. And then we looked at different examples and architectures of in securing software as a service, platform as a service, and infrastructure as a service. Then finally, we looked at different configuration options and putting our own systems in the cloud, or using Protegrity for multi-cloud environments. Thank you very much for joining today's session. We have still a lot of sessions planned coming up this year. Next, we will look at cloud security strategies in practice. So we'll demonstrate on actual systems how security can be applied for SaaS, PaaS, and IaaS. Then at the end of October, we plan to run a session that focuses on BI. After that, we will look at Protegrity Insight, so our solution to discovering sensitive data assets across the enterprise. Then we have a session on distributed SQL. Another one will be around test data generation. And finally, we'll end the series with integrating with metadata management tools. If you're interested in any of these sessions, please take a look on our website, protegrity.com/protegrity_APAC. Also, this is where you can see our previous sessions on demand if you want to rewatch them. Thank you very much for joining, and hope to see you in 2 weeks.